Hello everyone. In this video, we'll be understanding data preparation phase to model the data. Data modeling basically is the process to visually represent a data in a structured framework which defines the relationship between the data and how the data is organized. This presentation explored key steps in preparing and modeling data using Python. It will focus on foundational concepts and practical examples. Let us look the data preparation phases, which is partitioning the data and balancing the data. Split data into training and testing sets to ensure data generalizability. This allows us for accurate performance and evaluation. Balancing data, on the other hand, is to address imbalanced classes to prevent biased methods. Techniques involves like oversampling, undersampling, and synthetic data generation is used in balancing the data. Partitioning data with Python. Now, how to use Python to partition a data? Python sklearn.model underscore selection is a method or function to use for the partitioning of data. It's a versatile tool for splitting data into training and testing sets. It allows for easy control over the test size and random state for reproducibility. Splitting the data using Python train underscore test underscore split. We can effectively partition our data set using this function. The function takes the feature x, target the value variable y, and test size random state as arguments and returns the training and testing sets. Balancing training data. Now, how to balance a training data? Basically, we have three techniques: oversampling, undersampling, and synthetic data generation. In oversampling, duplicate minority class samples to increase its representation in the training set. In undersampling, we remove majority classes sample to create a more balanced data set. And in synthetic data generation, we simply create artificial samples that mimic and characteristics of the minority class. Moving forward, let's see how to build a decision tree. Decision tree is an important aspect to evaluate the values in the data set. Basically, it is CART and C5.0 methods. Classification and regression tree, CART, are used for both classification and regression tasks. On the other hand, C5.0 is a more advanced decision tree algorithm known for its pursuing capabilities. Building CART and C5.0 trees using Python. The decision tree classifier class static learns tree module provides a robust implementation of the CART algorithm, and you can specify various hyperparameters like creation, max underscore depth, max, mean samples, etc. We'll be looking how to build a decision tree in Python in our IDE using the code snippets. Python C5.0 sklearn does not directly include a C5.0 implementation. However, you can achieve similar functionality using the decision tree classifier only with a careful hyperparameter tuning to mimic the C5.0. Building random forests. Now, how to build a random forest? As we have seen the decision tree, and now we are seeing random forest methods. Bagging. First step is the bootstrap aggregation creation multiple decision tree on random subsets of data. Random subspace randomly selects features for each tree, further enhancing diversity. Assemble prediction. Combine predictions from individual trees to improve accuracy and robustness. Now, let us see some evaluating model performance. Basically, we have 4 steps in it. First is accuracy. How to evaluate model performance through accuracy. Measure the percentage of correctly classified instances. Second is precision. Represents the ability to correctly identify positive instances. Third method is to recall. Indicates the ability to create and capture all positive instances. And fourth is the F1 score, which combines precision and recall into a single matrix. And now Let's see the code in Python in our IDE for better understanding related to the data preparation phase of data modeling. You can see here pandas are pandas library is imported. sklearn.model underscore selection train underscore test dot split sklearn.preprocessing, standard scalar, sklearn.tree, decision tree classifier, sklearn.ensemble, random forest classifier, sklearn.utils, resample, sklearn.matrices, accuracy underscore score. All these packages are imported for the model of the data. Firstly, as usual, we have created the data frame for classification in which we have included data equals to pd.dataframe and then pass the parameters regarding the features and the targets. Moving forward, let's learn how to partition the data, train or test splits. X equals to data, passing the parameters feature 1 and feature 2, and then Y equals to data and passing the target. X underscore train, X underscore test, Y underscore train and Y underscore test is equals to test underscore split, passing the parameter according to the test size, range, etc. and then printing the desired training set size and test set size. Moving forward, let's see how to balance the training data set, unsample the minority classes. Train data equals to pd.concat. We have used here concat method. Majority class equals to train data passing the parameter in the target section and minority class train data passing the target equals to 1. Unsampling the minority class to balance the data set. Minority underscore class underscore unsampled equals to resample and passing the parameters minority class, replace value, ensamples and random state. Passing the parameter anyways, we can set the random state for any value. Now see how to build cart decision tree. Cart model and then decision tree, which we have imported the library of decision tree classifier. Random state again, cart model dot fit and then passing the parameter x train and y train balance and then printing the cart decision tree accuracy accordingly. Build random forest. Now how to build random forest? Random forest classifier is also imported in the IDE. rf underscore model dot fit, passing the parameter x train balance and y train balance and then calling the parameters, printing the desired outcome as for random forest accuracy. I hope you have understand the data preparation phase of model the data. Next, we will see more topics related to data science. Till then, stay tuned. Thank you.